Hi, my name is Sébastien Biorel. I'm the Director of Pharmacometrics and KIWI application at Cognigen. And today I will cover the new functionality that have been released with KIWI version 3. I will actually cover the following points, the update of the knowledge portal and the improvement in the security framework, essentially how you access KIWI. If you have been using KIWI for some time, you would have noticed a change, and you probably already know what I'm going to talk about. But I'm just going to describe this functionality again. The next point that I will cover is the implementation of automated model diagnostics in the KIWI Summarize module. Most of our time is going to be dedicated to the overview of the new modules for exploratory data analysis, Explore Live and Explore. Those are two separate modules that provide comparable functionality, but with some fairly significant differences that I'm going to try to highlight. There are actually a lot of functionality between those two modules that I will not have the time to cover. I will try to give you a demonstration of how to create simple exploratory displays in each of those modules. But we actually have created a fairly complete list of tutorial videos for Explore Live and Explore. These videos are available in a YouTube channel. You need to go online to YouTube, then search for the Simulations Plus channel. And in the playlist, you will see Cognigen KIWI 3 tutorials, and we have 44 videos covering in very extensively the functionality of Explore and Explore Live, and there's about 20 hours, if I remember well, 20 hours of video training. So you can go over those training when you have time. So I will now switch to the first topic, or the new feature that was introduced with KIWI 3, the upgrade of the knowledge portal and all the security framework. You now access to KIWI using that particular URL, portal.kiwifarm.org. And once you access to this portal, you will reach that particular window. You will then need to go to the left area and select one or many instances of KIWI have access to. In that particular instance, I'm going to use the Cognigen demonstration instance. And what it shows you is different tiles corresponding to the different modules or some modules of KIWI. In this case, I see the KIWI Workbench module, the KIWI Manage module, and the Explore Live module. You click on one of these tiles to open the corresponding module. And now I'm going to switch to the second topic of this presentation, which is the description of the automated model diagnostics that were introduced in KIWI Summarize. So we've introduced a new panel in the right region of KIWI Summarize. This panel includes 11 diagnostics, one per column, and this diagnostic will be run for every step of estimation. Diagnostics could be one of three levels, either good, questionable, or bad. Additional icons that you can see include these gray icons that indicate that a particular test could not be performed. Typically, it's because a file was missing. So let's say your model did not have a successful covariance. A lot of these additional diagnostics cannot be performed. So you will see a lot of those gray icons when you see a bad covariance result. The last icon represents the fact that the run, a particular run would predate the release of these automated diagnostics. So if you're using, if you've been using KIWI for a while, your historical runs would display this icon because we're not rerunning the diagnostics on all the NOMEM, the historical NOMEM runs. One of the reasons for that is because those diagnostics rely on files that were not necessarily loaded with the initial runs or the historical runs. So with the KIWI 3 release, we're loading a little bit more of the NOMEM output files, and we're using those files to generate all those diagnostics. Each diagnostics, so basically we implement threshold for each of the diagnostics for minimization, or should not use the term threshold, I should say rules, and in some tests threshold, or numerical threshold. So those thresholds and rules are different for each of the tests. You can have access to more details or more explanation on the different rules if you go to the KIWI user manual, which also gives me the opportunity to mention that we completely rewrote the user manual, and it has a different look and feel. You can see the navigation tree on the left. You have a search capability here. Regarding the model diagnostics, you need to go down to the either the sections relative to KIWI Summarize, or in the appendix. The appendix 1, section 1119, provide the complete sets of rules that we apply to deem that a particular shrinkage, the shrinkage for a particular run is either good, bad, or questionable. And you can scroll down to read more about those rules. It would take a little bit too much time to really cover the details of those rules. So let's now switch to the main topic of this demonstration, the new exploratory data analysis modules, Explore Live and Explore. I'm going to start with the Explore Live module and explain the design behind Explore Live. There are two ways you can access the Explore Live module. The first way is from the knowledge portal. You can open the Explore Live module by clicking on the corresponding tile. And this will open this module. The second way is from a KIWI Workbench or KIWI Manage. You can select a data folder and select a particular data file. In Manage, we have actually created a third default tab that lists all the data files that are available to you. And you could select one of these data files or actually one or more data file, and click on the Explore Live button. And the main difference between the two ways to access Explore Live is the source of data that you will use in the module. When you open Explore Live from the Knowledge Portal, you actually open a brand new interface, and there is no data available to you by default, and you can upload data file from your local computer. So by clicking on Browse, you can go to a particular folder of your drive and then select a data file and upload the data file. When you open Explore Live from Manage or Workbench, you're actually sending that data file or those data files to the Workbench, to the Explore Live module. And then you have to select which one you want to use, the same way you would in this version of this way of opening Explore Live. The rest of the application is the same, regardless of how you open the application. The difference is mainly how you go about selecting data for exploration. So I'm going to close this particular window of Explore Live, and I'm going to use this data set here. So the Explore Live is a Shiny application. It's entirely powered by R in the background, and it provides different features for creating plots, tables, and run various kinds of analysis. So today I'm going to explain to you how to create a scatter plot in Explore Live. And I invite you to watch the tutorial videos on the YouTube channel to learn about what are specifics regarding the bar chart, distribution plot, all the other plot table analysis submodules. The default quote-unquote submodule of Explore Live is the data module, which is the one that is open when you open an Explore Live page. You can see three different panels in the first tab. They allow you to upload or use up to 3 different data sets. Most of the time, you're going to use only one. But you can use multiple data sets and switch between the different sources of data to create your plots or tables. In each of the panels, you can see different selectors. They essentially control how the data file that is uploaded is processed and transformed into an R data object. The default selection should allow you to process a typical CSV data set with a header line and everything separated by commas. If you're uploading a text file that has a space delimited files, you could use any white space column. If you need to skip lines, you can use the last UI element. For example, if you have some text or description of what the data set is at the top, you can skip those lines. Something that it could be also important is the missing data indicator. By default, we're considering the NA, the dot, and NAN character strings. Those character strings would be interpreted as missing data for R. If you need to use a particular string of character or a particular number, some people like to use -99 or some combination of numbers. You could add those numbers here to indicate that these records would be actually missing data. So in this case, I've got a very simple CSV, so it does not really require anything special. You can see other tabs available in the data module. The second one is view content. You can select one of the many data sets that you've uploaded. In our case, we only have one. Below this panel, you can see a summary of your selected data set. This is a typical R summary of a data object or data frame. You can see quantiles of each numerical data. For character data, it's not necessarily super informative. Above that, you can see the number of rows and columns in your data set. At the bottom, we have a view that is more like a table view of the data set. By default, we're showing 25 entries. You can actually increase that here. You can scroll left and right to explore the content of your data. And you can use those numbers here to switch from a set of 25 to the next set of 25. You cannot use that view to modify data. This is purely read-only. So it's just to check that your data contains what you expected. There's a little bit of a search functionality here. It's fairly simple. It doesn't give you a lot of options, and it's very much matching an exact match of a string. So let's say I want to find something that is 2.5. Where would my 2.5 be here? Well, in this case, this was a 2.5 here. So 2.5, 2.5. So there's a, it's not really fancy, but it could help from time to time to find records that you would need to identify. The next tab is a tab that allows you to create copies of the imported data set and modify those copies. So you can create up to 10 modified data sets. You have to select the first one. You can give a nickname to this data set that would be used in the other modules. So in this case, I want to create a data set that is a subset of my source, and I will want to subset to the observation records. So to perform the subset, I need to use the elements that are in the second column. The main element is this field that allows you to enter a valid R conditional expression. And you will have to use an R syntax for that. The R language is case sensitive, so you need to make sure that you're using the exact spelling and the exact case of your variables. So in this case, I know that my SAMP variable is controlling what record is a dosing record or an observation record, and I will want to subset to SAMP equal 1. I will click on Save, and the module will show something that is similar to the view content with a summary of the modified data set with a count of rows of 1966. And at the bottom, I can see also the same view of the data in a more tabular format. So we had 1966. If we want to see if we actually perform a subset, we can go back to the view content, and we see that we have lost or excluded about 400 data points. There are additional subset functionality that you can add on top of a plain subset. You can further filter your subset by choosing a selection in this keep field. By default, we keep all the records from this resulting subset, but you can subset to the first record per subject if you're interested in, let's say, creating a table of subject characteristics, and you want to know what is the age weight of all your subjects, and you don't need to repeat the value of individual ages or weights more than once. So let's say I want to create a second data set, and I'm going to call that subject characteristics. And in this case, I will not want to subset anything. I want to just say keep the first record per subject. If I used any of these options, I need to provide the application with the variable that represent the subject ID. In this case, it was a simple ID variable. And I will save that. And now I'm down to 160 rows. If I look at the table, you can see that I'm switching from ID 1001 to 1002 and so on. If you need to be a little bit more fancy in your filtering, and if you need to consider not only the subject identifier, but covariable, if you have a time varying covariable, for example, and you want to have an idea about the distribution of these covariables over time, or include those variation of covariates over time, you can choose to keep only the unique duplicates of covariate sorry, you want to exclude the duplicate covariable and subject combination. Something that is a little bit more fancy would be to exclude the repeat of covariable. So the difference between those two options is if you have a subject that goes from a weight of 10 to a weight of 11 and then back to 10, the no duplicate option will keep only the first record with a weight of 10 and then the record with a weight of 11. The no repeat would keep the three records, the 10, the 11, and also the 10. So you get a little bit more records with the last option. This is described and illustrated in the user manual if you want to see more practically what this represents. So if you were to use a combination of the last two options, you would need to provide in the last field which covariable you need to consider for this filtering. I'm not going to use that here, but it's what you would need to do. So actually, I'm going to just demonstrate that you can enter as many variables as you want, and could delete that using your keyboard backspace. So so far we've described the creation of a copied data set, and these how you can subset the record in that copied data set. You can also perform some data transformation in Explore Live. So data transformation are typically the addition of a variable that would be missing in your analysis data set. Let's say you forgot to create something, categorical version of a continuous variable, like an age category or weight category, and you don't really want to go back to your either your data set or the program that created that data set, and you just want to have a quick look inside the application. You can create a new variable, let's say age group, and you will use any kind of valid R coding here. The expression that you enter in the last column could be as simple as age group equal 1. If I save, you can see that I now have an age group variable that is set to 1 on all the records. Typically, you want something a little bit more complex. We were talking about an age category. In this case, you would typically go with an if-else statement, where you need to go for, let's say, age lower than 25. You want to set that to 1. And you can even use nested if-else statement. And you want to say if age is lower 50, you want category 2, and otherwise you want a category 3. So in here, I deliberately not included a necessary closing bracket, just to demonstrate that if you save and if you have an invalid expression, the UI will tell you that in the first row of the transformation, the expression is wrong. It does not necessarily tell you what is wrong, it will tell you just where the problem is. In this case, I forgot a closing parenthesis, and I can save that. And now my data set has an age group that goes from 1 to 3. I'm not sure I would be able to demonstrate that. Yes, got some 3s, some 2s, no 1s though. But anyway, so I've got the ability to add up to 10 variables. Something that is dangerous, but it's possible, you can actually overwrite the content of a data of a variable that was in your source data. So if I wanted to mess with the ADDL variable and I wanted to, I don't know, do something not necessarily smart, but I set that to 1, I literally overwrote the ADDL variable. One of the useful combination of transformation and subset is when you want to create a categorical variable and you want to exclude or subset your data based upon that new categorical variable. In this case, you would need to change the content of the first tab and say, I want to transform my data before executing the data subset. The default is to do that after, but you can set that to default. And then in the conditional expression, you could say if age group equal 1. Not this one. I'm going to save, and in this case, I would only have 5 subjects that match that that criteria. Anyway, I don't necessarily want to do that, so I'm going to save that, transform that back again, and save. Other functionality in this data module are the ability to pull 2 data sets. If you've uploaded 2 data sets that you want to merge, or pull side by side or on top of each other, or do a more a typical merge by some merge key, you can use that. I'm not going to demonstrate that today, but you can. You have the ability to download any kind of transformed data set. You can actually re-download the original data set, which is not necessarily super useful, but here we list all the original and transformed data set. So you can download that as a CSV file. I'm not going to demonstrate that today, but it's a functionality that is available to you. So what I'm going to do now is switch to the plot, the scatter and line plot submodule to show you a little bit about how to work with Explore Live and what it allows you to do. Most of the modules have a pretty big plot area where the plots are going to be displayed. You have a data panel where you can select which of the data sets you want to use. So I'm going to select my PK sample. And then you have various panels that provide you basic settings or advanced settings. So in the case of a scatter plot, the basic settings are what is the x-axis variable and what is the y-axis variable. So in this case, I want to use DNCP. I want to explore the dose normalized concentration in this data set. Before I go and describe other functionality, I want to mention that this particular plot type is interactive. And by that, I mean that you can click on a specific data point, let's say this one. And what that does is it highlights the data point and give you some information about this particular data point. By default, we give you information about the X and Y axis variable. But if you need more information, like for example, the subject identifier value that provided that data point, you can add as many variables as you want. So in our case, we want ID. And you can see that the information now shows up at the bottom. If you have some kind of a variable, like in this case, we have this num variable that provide a record index that would uniquely identify this record, I can show it. And in this case, I know that that's my record number 31 that provided this particular data. I keep on scrolling too much, I'm sorry. You can add data points in the select data area by clicking on additional point, and as you click, the information is showing at the bottom. You can also click and drag your mouse to create an area, and all the data points within this area will be reported in the select data area. You can click on this copy to clipboard to copy the data, and then you can paste that in Excel, in any kind of text editor that you would need to maybe post-process that information if you need to communicate that record number in combination with the ID to your data programmer, or to your copy-paste that into a code to modify the data set. That's something you can do. You can click on reset to remove the selection and return to the default graph. So now I want to spend a little bit more time talking about the different options that you can play with for scatter plot. Typically, when you have a lot of PK data like this one, you want to start stratifying your data and look at different groups. So looking at dose normalized concentration, one of the things that I would want to see is different symbols for each value of dose. And that's what you can see here. By default, Explore Live considered numerical variable as continuous, regardless of whether they contain unique categories. Like if you had a sex F or a sex variable that contains 0 and 1, this would be considered a continuous variable. In my case, I had a dose variable with maybe 6 or 7 values, and what Explore Live does is it creates this gradient of color to represent the different values of dose from the lowest to the highest one. If I want to represent the data in categories, I need to transform my variable into a categorical variable, something that you can do in this field, coerce the following variable to categorical. I'm going to type dose. And now, yes, took a little bit of time to react, but now all my data points are shown with different colors and different symbols that are explained in the legend. So now I've got different data points. It's still a little bit crowded. I may want to do a little bit more to transform that data. Maybe the first thing that I want to do is maybe look at the first 2 days, maybe the first 24 hours of my data. Can define a minimum and maximum for the range of the x-axis. I will want also maybe to look at the y-axis from the point of view of a log scale. And now I've got something a little bit different. Well, maybe let me just remove this one because I want to use the entire range of data to show something else. Now I want to break up the data further than just by using those. I can use this paneling functionality here, and there's two ways you can panel the data or break the data into different panels. You can provide one or more data to break the one or more variables to break the data. So in this case, I've used the study and the SXF variable, and now the data, the plot panel shows some subpanels, one for each combination of study and SXF that exists in the data set. And you can control how many panels there are. So in this case, I have 2 by 2 panels. I can show more. But the one thing that I wanted to mention is if you have more panels to show than the product of these number of rows and columns plot, you can use this panel here to switch from one panel to another. You can use those arrows to switch from panel, the first series of panels to the next, and that can go pretty high depending on the combination that you have. So you can use the arrow, or you can actually type the panel that you want. If you want to change the layout, you can by changing the number of plot rows and panels and plot columns. That's one way to look at the data by panel. You can also panel using what we call the row split by, in which case you would get one row per value of the variable that you just selected. So in this case, study. And you can combine that with a variable that would do the same thing in the vertical direction. So SXF 0 and 1. So in this case, you can use only one variable for the y dimension and a single variable for the x dimension. And all the panels are shown on screen. One thing that I forgot to mention is, for now, I've been using only numerical data, but you can actually use variables that are contained into categorical variables. So the study, do I have a study C? Yes. The study C was a character version of the study variable. So the application handle also categorical or text-based data. So something that you can do also here is add reference lines. Let's say you want to have a look at the smooth lines, or add a smooth line. By default, you get an overall smooth line. If you want one line per dose group, you need to also line by that particular variable. In this case, that would create one line per dose group. I'm going to switch just quickly to the other version because it's a bit better to demonstrate the next feature I want to mention. I'm going to say just one. So it's just study one. There's another form of trend line that you can add. Is instead of using a loss, which is kind of a moving average of the data, you can actually use a central tendency that is based upon actual mean or median of your data points. So I'm going to choose median. And you can see that a median is now calculated at each unique value of the x-axis, and then those median values are connected. So you can see the tendency line could be a little bit more discontinuous in nature, or less monotonous, I should say. There's some additional functionality for you to display error variability around the median. A lot of things possible. You can create, use an alternative x-axis variable to calculate those means. In the case you would have actual time instead of nominal time, you would want to bin the data somehow using a nominal time variable. So there's some additional functionality for central tendency that I invite you to learn more about in the tutorial video. So that gives you a little bit of a flavor of what you can do with plots. I'm going to talk about tables quickly. You can create summary statistics table. So in this case, I would want to look at the subject characteristics. I need to select a data set. Then I need to select a list of variables that I want to look at. Maybe SEXF and weight. I need also to define which is the subject identifier variable. And as soon as I select these variables and the ID variable, KIWI will, Explore Live will create a table in this area. You can, well, the information is shown. I'm going to transform SEXF into a categorical variable to show you the difference between the statistics that are represented for continuous variable, which are typical mean, standard deviation, median, min, max. For categorical variable, you actually have the frequency and the percentage that those frequency represent in the data for each of the categories of that particular variable. You can change the or add statistics for the continuous variables and go pretty crazy. You can also break the statistics by groups. So in this case, I want to use a statistic or see statistics by study, and you can use as many variables as you want. They would be combined somehow and give you a more fragmented or broken down view of your statistics. And so in this case, I have one column per study and an overall statistic. You can change the design of the table, which is by default to show you the variables and the statistics in rows. The stratification would be in columns. You can so select the second one. The second one and the third one are only applicable for continuous variables. So in this case, my SEXF will not be reported. So this design shows the variable and the stratification in rows, and the statistics are shown in columns. The last one is kind of the mirror image of the second one. You have the variables in columns, the stratification, and the statistics in rows. So it's literally showing the same data in a different arrangement or layout, depending on what you need to report on. You can use one layout or another. This actually gives me, remind me that I forgot to mention the download capabilities for tables. You can download the content of this table into a Word document, an HTML document, or an Excel document if you need to maybe do some additional computation, or in the case of Word, if you need to report that. You can also download plots using the download panel. You can use various formats, PDF, PNG, JPEG. You can define the height and width and resolution of the output, and you click download to save the this picture to file. The one thing that I want to mention, which is a big design point, now that we've talked a little bit about the functionality of Explore Live. Explore Live is very much meant as a sandbox for you to play with your data, to explore its content, maybe go crazy on the exploration, and or not necessarily crazy, but more detail in the exploration. What Explore Live is not meant to be is something to create report quality graph tables. They can be considered as report quality tables, but the graphs are very much meant for you to look at in the application. If you download those graphs, they would look something similar to what you see on screen. So the size of the font may not necessarily be appropriate for you for your report. So that's one of the big thing is you should not consider the plot from Explore Live as report quality. The corollary to that design choice is that we do not save any of the output that you generate in Explore Live. So what that means is if you want to keep trace of what you've created in Explore Live, you have to download this file and save it somewhere on your file. We will not store that particular plot in the KIWI database. If you close the Explore Live tab, everything that you've done, including the upload of data set, the creation of graphs, all that that setting definition that you've worked on, you will lose that. And again, the reason is because Explore Live is meant as a sandbox, somewhere where you can play with the data. And that's the big difference between Explore Live and Explore, which is the next module I will talk about. Explore is the mirror image of Explore Live, but the intent is to create report quality graphs and tables and to store these graphs and tables. We will work out of data files that are inside the KIWI database. And as soon as the files are in the KIWI database, it means that you cannot transform them. You need to either upload a new version of that data set or create a new file with a different name and upload that new file. So how do you access to Explore from within KIWI? You can access from Workbench or Manage. So in Workbench, if Workbench wants to open, would be great. You can upload a data file from your data group or from your own disk drive, and then you can select it and click on Open and select either Explore or Explore Live, but in our case, we would want to use Explore. The action of saying open this file in Explore and Explore Live will actually store the data file into the KIWI database. So once it's in the KIWI database, it will actually be shown inside the Manage page. So in this case, you can see I have 3 data files, but in Explore I have more. I have this back file that is not saved in the Manage page because it has not been loaded in the database, quote unquote. So a little subtlety here. So from here, I can select the Explore option to open the Explore module. The Explore module looks very similar to the Visualize module, which is intended for model diagnostics. Explore is essentially the Visualize for exploration of analysis data sets rather than model diagnostics. So on the left side, you can see a navigation tree that organizes the different EDAs that I created previously. So you can see that I have created in the past different EDAs that have been stored and organized. I retrieve that information by opening the Explore module, many days after the creation of those particular EDAs, and you can see that they're still there and they're permanently stored in the database. The center region is obviously the place where you can visualize the plot or view the plot or tables. It's a similar design as the tables that you've seen in Explore Live. So Explore looks similar to Visualize, and it shared a lot of design features that Visualize and Explore both implement. The first thing that both modules offer is the ability to display plots and tables. Well, in the case of Explore tables, you can show those displays for many data sets, which is not something that is super useful for analysis data sets, because typically you work out of a single analysis data set. But the thing that Explore also allow you to do is explore the content of NOMEM output table. So if you go to a stage directory and click on the data for exploration, KIWI will list the tables that are associated with these different runs. And I can select one or more of these tables and open Explore for these different tables. What it means is that you can create EDAs on NOMEM output tables. So if there's something that you cannot create in Visualize, like a specific graph for model diagnostics that you cannot create in Visualize, you can use Explore to have a more granular view of your data, or explore the content of this NOMEM output in a more specific way, or in a more user-defined way. And you can create these plots. I'm going to run that. It's not going to necessarily create something meaningful for these tables, but you can run one set of EDAs for all model table at once. The same way you could run multiple GOF profiles in Visualize for multiple runs. So, long story short, what I meant by that is Explore allows you to look at multiple files at a time, create multiple EDAs at a time, and possibly compare them. I don't think I got anything from the, oh, no, I got something. So you could look at the result and compare that result across tables. I will come back to my my analysis data set actually, and talk a little bit more about how you can create EDAs in Explore. And the way you generate EDAs in Explore is by clicking on this Generate button. It will develop this menu that lists all the categories of EDAs that are available in Explore. And for each category, you can see a list of what we call profiles. Some are a default profile, like this global. The other ones are profiles that I have created and that are customized to a specific need. The way you create those profiles is by using the configure window, menu, and open one of these items. The EDA profile is the one that you want to select to create an EDA profile. If you are familiar with KIWI Visualize, the concept is the same. You create a GOF profile or a delta plot profile. The difference is that in Visualize, the profile configuration window is shown as a pop-up. I'm going to actually show you the difference in Visualize. So that's a Visualize page. Can open, that would be great. If I want to configure a plot profile, I have a profile manager that is just a pop-up within the same window. For Explore, the profiles are a lot more complex. There's a lot more settings, so we've decided to create a specific window that is separated into 4 areas. In the top left area, you can select the type of EDA or the category of EDA that you want to work with. So scatter plot, bar chart, histogram, box plot, pairwise plot matrix, SumStat. As you select a category, the content of the second and the third area change. The middle area is where you can see the list of profiles that are currently available. By default, you will see this global profile, which is not something that you can change, but it serves as a reference. You can select that profile and copy or create a new profile by copying global. So I'm going to give a name to that new profile. And now I've got this profile that I can configure in various ways. And the way you need to think about configuring profiles and more generally creating EDAs in Explore and Explore Live is kind of an application of this 5-step process. First step is to select the data source. So in Explore Live, you had to select a data file or upload a data file. In Explore, you just had to select the particular file you wanted from Workbench or Manage, and that was essentially that step. The second step that you need to think about before anything else is what is the data subset that you want to use? By default, Explore and Explore Live will use all the data record, all the rows in your data set. If you don't tell those modules that you are interested in a particular subset of data, they will just go ahead and use everything. So if I'm interested in only the PK samples that are not below the limit of quantification, I need to tell the application to use those records in a particular way. I'm going to illustrate how to do that. Then you start thinking about what are the basic settings, the basic options of my EDA. My example of a basic option for scatter plot is why is my X and Y axis variable. It's going to change for like a table or a box plot. You would think about the basic option as what are the variables that I need to include in my tables, or what are the continuous and categorical variables that I need to consider in a box plot. Then you need to think about the stratification. Do you want to break the data onto different pages of plots? Do you want to break the data into multiple panels within a page? Do you want to break the data into different groups within a panel using different symbols? So this is something that you need to think about before you start thinking about the advanced option, which could be your axis title, their range, your transformation, and so on. So those are the 5 steps that you need to keep in mind before or when you create a profile in Explore. So the first thing I did was to select the data. I'm working with this analysis data set. I've opened the Explore, the EDA profile configuration window for that particular data set. The next step is to select a data subset. So I will click on this particular button that will open a panel in the center region, in the bottom region, which is essentially a dashboard. For subset, you can provide a global data subset using our expression the same way you do in Explore Live. So in this case, I will want to use, I'm not sure about that particular, I don't remember that particular data set, but let's say I want to use DVID equal 1. Maybe no, I do remember this data set. It doesn't have a DVID, it has an EVID variable. And I'm going to say I want EVID variable equals 0 for the null-mem observation. And let's say that I want to only look at that from the point of view of the first study. I can also use those filtering options that were available in Explore Live and use some sorting options and so on. So this is my basic subset that I want to use for my plot. And let's say I want to look at the data. I want to create a scatter plot. I could create a line plot or a line and scatter plot. And we'll talk about the do not show data option that seems to be a little bit counterintuitive as an option, but it's quite useful actually. I'll talk about that a little bit later. So here, KIWI has this default entry for the X and Y axis option. What it means is that there is a default, an expected default X axis for scatter plots in KIWI, which are the time variable, the TSFD variable, TSFE, I think, variable. And there's a set of variables that if they are present in your data set, you'll get a plot that would use this default one. The default X-axis variable is the DV variable. If I want to be a little bit more specific about what I want, I just click on the field and then select the TSFD versus, let's say, DV. And that's my basic setting. Now let's talk a little bit more about stratification. So I mentioned 3 different types of stratification in my introduction of the profiles or the stratification concept. You have, you can see a stratification tab. The stratification variables would be the variables that you want to use to break the plots or the tables, or in this case, it's the scatter plots or the plots onto different page of plots. So I want to see something different well, study is not necessarily super useful given that I'm subsetting to 1, but it doesn't matter. I'm going to use it anyways. So that's the variable of the variables, plural, that you can use to break the data by page. The conditioning tab is where you can define the variables to break the data with onto different panels. So let's say I want to use the sexf variable, and I'm going to just enter something in this field, and I'm going to explain it later. But you can use many conditioning variables by clicking on the Add button. You can add a new row and enter a second, a third, a fourth variable to a panel by your data. And finally, if you want to create different symbols by groups of data, you need to select one variable in the grouping variable field. And in this case, I'm going to use, what can I use? I have a dose. Yes, I have a dose, and I'm going to use that. I'm going to set that to false for now. And so now I've got my stratification defined. I'm going to change that layout to use 2 plots per page, or display 2 plots per page, and then I'm going to generate that profile. I can actually clear the dashboard. So I can either click on, select the profile and click on the generate button here, or I can go back to my explore window and use the generate button. The problem is that this menu doesn't know yet about my new profile. I need to click on refresh to refresh the content of the navigation tree and also the list of available profiles. And I can so click on this profile. You get a little pop-up that indicates that something is running. You see a message in green that something is running. You refresh, and this is available now. And now you can see that you have a plot that is subsetted by the study variable. So in our case, we have only one study, so I only have one. And you can see also an overall version of that, the same plot. So that would completely disregard the stratification by study. Again, in this case, it's nearly the same plot because I have only one study. Then within one page, I have one panel, two panels, or one panel for each value of the SexF variable. And within each panel, I have a different symbol for each of the dose groups that were available. So that's what you need to do to create a very basic, simple graph. The advanced option that you can use in for scatter plots are many, actually. The thing that you can do with scatter plot is actually use a secondary y-axis variable. If you want, if you have, let's say, a PK/PD analysis data set, you can overlay your PK record with your PD record on the same graph and use the right axis for your maybe PK or PD and the left axis for the other endpoint. You can use multiple y-axis variables. So if you want to overlay different variables from your data, let's say you have a variable that has a parent drug, data set that has a parent drug concentration variable and multiple variables, one for each metabolite, you would be able to select those different variables and display them on the same graph. Things that would control the secondary y-axis are under the x-axis, the secondary y-axis UI. You can something that is available in all the category EDA categories is a set of functionality related to how BLQ data should be handled. The default is to do nothing. You can choose to exclude or transform the dependent variable value for BLQ records either to 0. I'm actually going to show you that. I need to change that from a view to an edit mode. If I go into edit mode on a profile that has been executed in the past, KIWI will recognize that and will ask me to confirm whether I want to edit, and the consequence of the edit would be the rerun of those plots on this particular data set, or all the data sets that would be listed here. So that's what I want to do. And so, as I said, you can either do nothing for the BLQ, you can exclude the BLQ records, you can set the DV variable to 0, have the LLQ variable, or to the actual LLQ variable. When you use one of those those 4 options, you're going to need to define which of the variable is identifying the records as BLQ or not. So typically you've got some form of BLQ FN record somewhere, variable somewhere. Regarding the LLQ, you can either choose a variable that would store the value of the LLQ for each record, or if it's the same value across your data set, you can actually enter a numerical value here. And so what that will do is, if you want to, let's say, set the variable to LLQ, before KIWI create any kind of plots, it will modify your data set on the BLQ record and transform the DV to 0.5. And that information will be shown as 0.5 on your plot. Or if it was a table, it will show as 0.5. Things that you can also, I'm going to just revert that back to do nothing because there was no BLQ variable in this particular data set. In terms of the axis, you have the same options for the x-axis, the y, the primary y, and the secondary y-axis. You can set a variable. The default, the fact that it says default, it means that KIWI will try to find a label that is stored in the label library that I will talk about a little bit later. You can set the minimum and maximum of the axis range. Default means that essentially KIWI automatically detect the range. You can choose to show the data on a logarithmic scale. And if you want to apply the transformation function, you can actually enter an R function. For the x-axis, typically the functions that are useful are unit transformation function. So we provide a lot of different unit transformation function. The list is available in the user manual in one of the appendix about valid R expressions. And for example, one function that could be useful is the transformation from hour to day. This H2D function would transform your x-axis from an hour unit into a day unit. Other transformation that could be useful are the multiplication by a power of 10. So you want to multiply the data by 3, something that would be more appropriate on the y-axis actually. So the E3 is multiplying your values by 1000. The E minus version would divide your values by 1000. And you can use anything between 1 and 9. So you've got the E minus 1, the E minus 2, the E minus 3, and so on. So those are transformation functions that could be useful and would allow you to avoid having to modify your data set or recreate a version of your data set that would be modified. Stratification we've covered. Lines and data summarization are meant to for spline lines or reference lines, either horizontal lines or vertical lines. You can create a slope like a unit line. You can create that from this panel. Here you can create data summarization, so the trends by mean or median plus or minus variability, you would define them here. So it's something fairly similar to what you have in Explore Live. It's a bit different. There are some subtleties that are covered in the tutorial videos that, again, I invite you to watch. So let's give you a little bit of a flavor of the advanced functionality for scatter plots. There are obviously different functionalities or options for bar charts. You can see that the list is a bit different. Histograms, box plots, all those different profile or EDA categories are covered in different video tutorials. Or if you want to read the user manual, we also have a fairly extensive list of examples of things that you need to modify to achieve a particular design. The last thing that I want to mention is something about this variable definition menu or configuration window. It is typically separated into two areas. The left one is something that would list what is the variable associated with the subject identifier, dependent variable. You could see independent variable on other categories. And if you see default, it means that KIWI will look inside the data to find something that is a default variable. For subject identifier, we would look for ID. For dependent variable, we would look for DV, and so on. On the right side, you can see this covariable panel. And here you can define or include one or many rows that would define what are the covariables you want to include in this particular summary statistic table. If you were looking at histograms or box plots, you will need to define in here which are the covariables that will be part of your box plot profile. So if I look at this particular box plot, I created box plots for the age, creatinine clearance, and weight. So I had to define that age was a covariable, that dose was a categorical variable, ethnicity was another one, and gender was another one. So this variable definition is what you would look as your basic settings for histogram, box plot, and SumStat table, as well as the pairwise plot matrix. So I'm just seeing the time flying, and I want to mention a couple of things before I open the floor for questions. I mentioned that early on that Explore and the Explore and Visualize module share a lot of functionality. So the basic shared functionality is kind of the organization of the UI. The second one is the fact that you have to create profiles to generate plots or tables. Those profiles are actually transformed into R scripts that are executed in the background, and those R scripts are actually the things that create your plots. You can have a look at the log files of the execution of those R scripts. So when you see a message in log in red, it means that there was a warning or an error message in the log file. So you typically have to go in the bottom part after this end of settings. This mark the beginning of the actual execution of things like the import of data or the creation of plot. Things that start with this **1 triggers the display of this message in log. So some messages are, and it is the same in Visualize, the same warnings in the log file would trigger the same messages in log. Some messages are not necessarily consequential or important. In this case, we inform you about the existence of missing data in various records and various variables. And so it could be completely expected. And the rest of this thing is fine. So I could decide to suppress the warning and say, okay, this is fine. I just want to ignore that warning, and now this is removed from my tree, navigation tree. So that functionality is completely shared with Visualize. The other thing that is shared with Visualize is the concept of format collection. It works exactly the same as in Visualize. So the concept, just briefly, is gives you the ability to transform. So this custom is exactly the same as this demo option, but the demo in the demo profile, I did not use profile data profile formatting, sorry. And you can see that the SEXF and the study are reporting numerical values. You can create a format collection to associate a text value corresponding to the 0 or 1. So just briefly, you would create different formats for the different variables that you need to format. For SEXF, you would provide the values and the text associated with these values, and then you would associate those formats to the variables that you want to format. It works exactly the same in Visualize. You actually share the profile collection that you create in Explore. They are visible in and usable in Visualize. If you make a modification in Explore, it will be reflected in Visualize. You create a new profile collection, a format collection in Visualize, it would show up and would be available in EDA. So it's completely 100% shared. You can also import those profile collections from different projects. Something that I forgot to mention for the actual plot profiles, you can actually also import plot profile from previous projects that you would have executed. Another thing that is shared completely with Visualize is this library of default labels and units. So when you start working in a brand new project, actually a stage of a project, you will see that that window will only show rows in white, which essentially reflect this default library of labels and units corresponding to default labels, variable names. You can either modify a default label or unit, and in this case, that row would become green. I can revert that back to the original by actually deleting it. You can add a new variable that you want to, for which you want to provide some custom label, and that would also show in green. And you can delete that if it's not appropriate. So that's why you see some rows in green, some rows in white. And that list, that library is 100% shared between Explore and Explore Live. These labels are used for axis, titles, navigation tree, the folder names, legend. They're used in many places. Units are used, for example, here in the legend. They could be used, I believe, in the strip and in the titles, as well as in the folder name. So there's many places where that information is very useful to customize for a particular project. The last piece of shared functionality is this concept of variable categorization. When you upload a data set, KIWI extract the list of variables, and by default, it assumes that they have this default category that we call other. You can assign a different category, like a continuous covariate or categorical covariate, to relevant variable. So age, CRCL, so my creatinine clearance, weight were set as continuous variables, while SEXF, ethnicity, dose were set as categorical variable. That does not really change a lot what KIWI does or how it used that data, although it kind of forced certain behavior, but it does not limit you in like creating a scatter plot using the dose. It's not because this is categorical that the scatter plot cannot be created using that dose variable. but it is useful to control the default behavior. So, for example, the default box plot profile will use all the possible combination of continuous and categorical variables to create box plots. So that's how useful it is, or the main use of this categorization. Other piece of shared functionality, you can zoom in and out in here. You can view the names of the files. You can export out of Explore. You can select a particular plot and export that selection, or you can decide to export all the EDAs that are in the selected folder in the navigation tree. So if you select something that creates many plots, instead of going and selecting one plot at a time, you could select an entire thing and say, well, give me everything into a zip file. So EDA in selected plot only. KIWI will compress everything in a zip file that you can download. Plotting option, you can reduce the size of the plot that KIWI creates by 50% if you need something that is a little bit smaller. If you want to export a table, you can export that as an HTML, a Word, or Excel format. The information about source also can be included at the bottom of the picture. So if you, let's say, this plot natively doesn't include anything about the source of data. If I export with the inclusion of source and show that, I think I need to move that here, reduce that a little bit. You can see that information is inserted automatically upon export. It gives you information about the KIWI version, the file ID, so that's the ID that uniquely identify your data set, and the profile ID is the number that uniquely identify this profile. You can also include the file name, so the thing that you were seeing here, that could be inserted also in the exported plot. So that gives you a quick overview, or not so quick overview of the functionality of Explore and Explore Live. Before I open the floor for question, I want to just cover a few more points of conclusion. So I mentioned already the similarity between Explore and Explore Live in terms of design, shared graph library based upon R, shared format collection, library of labels and units. Before I conclude, I want to stress again the difference and the similarity between Explore and Explore Live. Explore is meant for permanent storage and report quality graphs. Explore Live does not store the data, does not create quality plot. Well, what could be identified as quality plot, I think it's pretty good plots, but not necessarily match what would need to being implemented for a report quality plot. The difference is that Explore Live provides interactive plots. Explore does not provide any interactivity. Once you created a plot, it's basically a PNG image that you cannot click on or further investigate. You have to modify your profile to really modify what you see if you want to work in Explore. Explore provides organization of your display. Explore Live does not. Explore Live provides ability to manipulate your data. Explore does not. Both provide subsetting functionality and similar types of EDA types. Explore Live provides some additional plot like a survival, Kaplan-Meier plots, things to explore data binning for VPC, linear regression, and so on. There are some additional functionality that differ between the two. I'm not going to go into too much detail about that, but in conclusion, I think that what I want to say is that Explore and Explore Live are not necessarily better. One module is not necessarily better than the other. I suggest that you learn to use both modules and see what are the strengths and the limitation of both modules. And essentially, you have to use the module that better suits the particular need for your exploration. So if you really need to identify the data point, maybe you need to look into Explore Live. If you need to create an EDA that would go into a presentation or a report, I would suggest that you use Explore to do that. So again, yeah, learn to use both and find what works best for you. Again, if you want to learn more about those two modules, I suggest that you go in the Simulations Plus YouTube channel. That link here is a bit complex for you to write down, but this is the shortcut for that playlist of KIWI 3 training videos. So now I'm going to open the floor for questions. As I mentioned, everybody is muted, so if you have questions, you have to use the chat. And if you have any question after this presentation, please feel free to send a question to actualkiwisupport.cognigencorp.com. Okay, so I don't see any question coming in, so I think I will conclude this presentation by thanking you for attending it. We hope that you're gonna have fun with this and you're gonna find those new functionality useful. If you have any question after this presentation, feel free to send an email to our support email address. Okay, well, thank you very much. Bye-bye.